The last example, example 8, is a word problem. So let's take a look. Akemi drives all afternoon to visit her family. Her distance traveled, in miles, t hours after starting out is given by this function. So what are they giving us? This function will give us how far she traveled, and the input is how many hours she's been traveling, right? And I can see that her journey stopped. She stopped driving after what, 5 hours? But if we plug in any number in between 0 and 5, we'll be able to figure out how much she traveled in that time frame. Okay, so let's see. The first question, find the distance Akemi has traveled. So, all they're asking is the distance. So we're not really doing any calculus yet. We're just finding the distance given the distance function, and they're giving you that the input is 3. So all I'm going to do is find f of 3. Plug in 3 into the function. 1.85, 3 cubed. How far did she travel, I wonder? Minus 18.175, 3 squared, plus 82.51 times 3. I know some apps you can just take a picture of this and they will evaluate this, but I got my old-fashioned scientific calculator with me. So I'm typing this in, and I may make a typo, you know that. So if you are watching this video and if you got a different number, different answer, I want you to leave me a comment or write me an email, okay, so that I can fix it. What I got is 133.905 miles. Okay, so that's my answer. So at the time she drove 3 hours, she already traveled 133.905 miles. Okay, so that's simply describing her distance. Okay, what's the next one? We'll find the instantaneous rate of change. We're finding the instantaneous rate of change. So this, finally, we're not talking about the first derivative. We're talking about the slope of a tangent line. And we're going to say that's the velocity, how fast her position is changing toward the direction, toward a certain direction. So what you're going to need to do is anytime you see these velocity problem, you're going to find the first derivative. Okay, so find first derivative and plug in the same input of 3. Okay, so what we're trying to find is, assuming that she's driving to the same direction the whole time, she's not going back and forth. Like, you know how some people get lost in highways and take the wrong exit. Like I take an exit to get some Popeyes and accidentally take I-95 southbound, and I'm supposed to go northbound. But assuming that she's not making that mistake, she's traveling the same direction, we should be able to find her speed. We should be able to find out if she's speeding or not at hour 3. Okay, so find f prime of 3 first. Let me go ahead and write down f of t right above. You know how we talked about power rule today, so we are still pretty new to this derivative. We'll do it very slowly together, okay? 82.51 t. So let's find the first derivative. What we do is, remember, we're going to multiply the power by the leading coefficient. So multiply on your calculator. I'll do 1.85 times 3. You should get 5.55. 5.55, and what should be the new exponent? 2. It went down by 1. Let's look at the second one. Multiply the number. Well, that's a negative number, so I'm going to multiply a negative number. 18.127 by 2. 18.175. 175 by 2. I got 36 minus, whoopsie, that's the highlighter, minus 36.35. 36.35, and I wrote dt, The new exponent should be just 1 because we go down 1. So I will not write t to the first power. I will just write it as t. Now the last one is is 82.51t. And if you want to, keep on using that power rule, you can say that the number is 1 for the exponent so that you can multiply 1 times 82.51, which is going to be just itself plus 82.51. Oh no! What happened to my iPad? I'm losing connection all day long. All right, let me connect it again. Ah, awesome. So we're back. My 5 is bleeding over there. 51, and it's going to be t to the 0th power, but as we talked about this in class today, anything to the 0 power is 1, so I do not have to write this. It's just going to be 82.51. We're done finding the first derivative, and I keep saying first derivative, but we haven't done any other. Later we'll talk about second derivative. All right, now plug in 3 in here to find the instantaneous rate of change at t equals 3. So plug in the 3. So how fast is she traveling to her destination? That's what we're trying to find. All right, let me plug this into my calculator, okay? 5.55 times 3 squared minus 36.35 times 3 plus 82.51. I got, where is she driving? Oh my goodness, 23.41 miles per hour. No wonder this girl is taking 5 hours to get to her destination. This is her, hey, you know what? Who knows, maybe she's driving, I don't know what's going on, but that's how you find the instantaneous rate of change or velocity at a given t or input value. You find the the first derivative, and then you plug in that input value they give you. We'll look at a couple more examples later, but this was I think the first application problem that we did using derivative. Okay, so I'll come back with 1.6, the next section for the online portion of our class later this week. Okay, I will see you later.